their angles. A couple extra little bits of information about isosceles and equilateral triangles. One of them is going to be called what's called the vertex angle. Okay. When you have everybody else knows that an isosceles triangle has one pair of congruent sides, correct? Okay. More often than not, when we draw these out, we usually show the congruent sides to be like a teepee, if you will. Do they always have to be up and down? They can be sideways, they can be upside down, they can be anywhere, okay? It's just a more traditional way that people see it. That's just how it looks. That vertex angle is always the angle in between the set of congruent sides. So if you think about it, when you have an isosceles triangle, it kind of shows like it's a side angle side. Remember, the angle will be between the two sets of congruent sides. Okay? Now, a couple of ways that isosceles triangles are written out. You can write them out two different ways. One of which, you guys have this on? Can I? No. All right, I'll wait. I'm sorry. Don't mean to get ahead of you. Slowing down. I'm sorry. Why not?
Why are you guys hating?
Makes me sad. All right, so a couple ways you can write this. One of the ways to write or to draw a diagram if this is isosceles is if you're given something like that where it says triangle ABC is isosceles. In this case here, does it designate which letter is the vertex angle? No, it doesn't. So when this is the case, it's always going to, bless you, it's always going to be the middle letter. So if it doesn't tell you what something is a vertex angle, the vertex angle is always the one in the middle. Okay? Whereas the other way it could be written, it could say that triangle XYZ is isosceles with Z the vertex. Oops. This over here. Move this up. So the first way is this. The second way is this. Notice the difference. When it says triangle ABC is isosceles, it is just assumed, this is the one time you can make an angle side out of yourself, it is assumed that the middle letter is the vertex angle. When it tells you what the vertex angle is, that's when you have to make it. Okay? So when you label that one out, this XYZ, it'll look just very subtly different. You can still label your X, Y, and Z, but if Z is the vertex angle, what are going to be the two sides that are congruent?
X and Y.
Which sides?
Which sides? Yeah. That's the difference. Does that make sense? That's the difference. It tells you that this is the vertex angle, which means the sides that create it are the ones that are congruent. So if it tells you, you have to move your sides around. If it doesn't tell you, you can assume that it's the middle letter. It's a very subtle little trick that they do on these types of problems. Okay? Does that make sense? It's very subtle. It's just called, I don't know, reading.
Is that a new form of technology?
I know, it's a new form of technology. I heard they have it on computers if you log into it.
Wait, Mr. Murphy. Mr. Murphy.
Yeah, what's,
If it tells you it's what?
I'm sorry, what was the question, Bud?
If it tells you what is it?
The vertex angle. If it tells you the vertex angle, then you have to move your sides around to make it fit. Okay? Excuse me. Yeah.
So you wouldn't be able to do like X, Y, and Z every time? want it if it was like, if it told you? which
Oh,
one
sure,
was
you can do that. You can still direct. Absolutely, yeah. As long as the vertex angle, all I'm saying is that it just makes those two sides that are with it. So, yeah, it's just normally whenever I draw something out, yeah, because if you did it that way where Z is the vertex angle, if that's the vertex angle, it's still going to be the same sides.
Okay.
Okay, does that make sense? I was just trying to show it that it can be switched over because people write letters in that order, just to show it. Yep, okay. Now, one of the other properties of isosceles triangle, you get this. Whenever you have isosceles triangle, you have a pair of congruent sides. So if you have a pair of congruent sides, and this is something we discussed before, that means that the angles opposite the sides are congruent to each other. So what happens is, if these are congruent, then the angles across from them are congruent to each other. Okay. They're called base angles. So if you have, these are called base angles. Okay? So, and it goes the opposite. If you have base angles that are congruent, then the sides opposite them would also be congruent. It works going both ways. This is what we call a biconditional statement. Not to be confused with a bisected situation. They're opposite. So the angles, whenever you have an isosceles triangle, the base angles are also congruent. That's it. Yep. And then if you have, and it goes the other direction then, guys. Then if you have base angles congruent, then you have sides congruent. Works the same way going both ways. Biconditional. What's nice about isosceles triangles when you're dealing with angle measurements is that if you have a triangle and you know it's isosceles, and let's say that this is 100 degrees here, you can find the other two angles rather easily. Because you know those two base angles have to both add up to equal how much? 80, and they have to be the same, so what's half of 80? 40. See how fast that works itself out to be? You know that these have to be congruent, which means you know that total degrees is 180, so divide it out, and you're left with that. It's a very, very simple thing to do.
Can we get a couple of those boys on the
Maybe.
Like the entire chest all
The other idea was the equilateral triangle. Now remember, an equilateral triangle has all three sides the same. And if it has all three sides the same, it's going to have all three angles the same. So we've talked about this from before at the beginning of the chapter, when we said that equilateral it works out to be equiangular. And since there's only 180 degrees in a triangle, if all three angles have to be the same, that means all three angles have to be 60. Okay? Again, it is bless you, it is a very, very easy scenario to work with. Works the same way as isosceles triangles. If you have all three sides the same, it means all three angles are the same. If you have all three angles the same, you're going to have all three sides the same. Works going both ways. Okay? Very, very simple. We will actually spend quite a bit of time working with an equilateral triangle starting the second semester when we get into our 30, 60, 90 triangles, which works out to be the basis of trigonometry. It works out to be the big giant unit you do second semester of Algebra 2 a year later, which is just...
And if you don't have that nice calculator, hold yours up, it would behoove you to get one as soon as possible. So with
yeah.
Christmas coming up,
Hey!
I'd say, hey, Grandma.
yeah.
Right?
I would say,
No,
hey, Grandma.
here's the thing. Grandma's going to forget she gave you the $15 to buy the calculator before Christmas, so you'll still get something.
Hey,
Not, you know,
Understood.
and
We got plenty of
even if they remember, they're going to want to still get you something else. It might be socks.
Look,
Fun socks are fun socks, and that's okay.
or just
Socks are great.
Try to keep your toe. You're right, I don't believe all my heels.
Yeah. Don't want to have cold heels and ankle boots.
I think you aren't over this.
Oh my God. Not puns. Oh, big
Hey,
fella.
so if. Good night, everybody.
You'll be here all night.
Okay, again, guys, this is really, really fast. This is an equilateral triangle. One side is 15. What's the perimeter? Very good.
You said it's on 12. That's what
Do you remember what perimeter meant?
Around it, the fence.
Around the fence, very good. So, knowing that you have an equilateral triangle has all the sides being the exact same amount. If one side's 15, all sides have to be
15.
So last time I checked, 15 times 3 is? Yes, a lot of this stuff is quite literally that simple.
The catch.
You're so worried about stuff, aren't you? So,
It's always a good choice.
not really.
Yeah.
May not have it open?
YX plus 2y times pi square root of 7.
Lot of trees have been killing.
Well, I have to because the computer doesn't work. It's not working, so I have to do this. So, let's do this. I've got a couple examples that I put on the review that I wanted you guys to be able to download and have on your computers and look on the screens and redraw pictures and save trees, but no. So I went and took the advantage of the fact of just saying, hey, whatever. And I accidentally kill a couple of trees and see what happens. So, ladies and gentlemen, excuse me. What's that? I tried. I actually got myself together and realized that I didn't have to. Oh. So, what I want to look at here. Nice. What I want to look at here is a couple examples that deal with isosceles and equilateral. So let's look at number 4. On number 4, you will notice that it is an equilateral triangle next to an isosceles triangle. Bless you. So when you work with stuff like this and you've got side lines, you have to be able to figure out what matches up with what. So knowing that you have an equilateral triangle, what I would do, or actually we only know that we have equiangular for right now, but knowing that the rule is if the 3 angles are the same, the 3 sides also have to be the same. You okay with that?
Yeah.
Now, since I have single tick marks for all of these, I look to my next triangle. My triangle on the left, or excuse me, on the right here, is an isosceles triangle. An isosceles triangle has sides that are opposite the angle that are congruent to each other. So, if this side has a single tick mark, what does this side need? A single tick mark, because it has to be congruent, since they have to be the same. So now, if you look at it, algebraically to solve for x, what do? That's it. We then can say that 6x minus 5 is x plus 5.
You had to mark your diagram though, you guys, for you to see it, right?
And that's the idea to be able to do this. Marking diagrams, drawing pictures. It's like one thing that we try to teach you in geometry is how to draw pictures. So very, very easy algebra. Add 5, subtract x. We get 5x is 10. What's x?
That was Caleb.
Okay.
Debian.
Not too terrible? Bless you. I'm sorry, what's that? I think this one just said solve for x. Yeah, find the value of x. Okay. Flip over, ladies and gentlemen. And look at number 7. On number 7, you will notice, guys, you will notice that you have, excuse me, you've got a couple of sets of isosceles triangles. You will also notice that you're given one of the angles is a right angle. Okay with that? Now, our vertex angle for the triangle on the left is 51 degrees. So if that's 51 degrees, and we're working with the triangle on the left, how many degrees are left for those two angles? Well,
The bottom one is the right angle is 90.
well, that's not just this part. Okay. What we need to do here is figure out, well, how many degrees are in a triangle? 180. If I subtract out 51, what do you get?
129.
Use your calculator. Now, if it's 129, that means these two angles that are the base angles have to add up equal 129, and they both have to be the same. So what do? You cut it in half. Well, what's half of 129?
That would be.
Why wouldn't you add the 194?
What's that?
No.
Because that 90 isn't part of the triangle that I'm looking at. The triangle we're working with right now is this one. It's 51, something and something. Yeah.
And then right away you guys go, wait, it's a decimal answer. I must have made a mistake.
No, we did. No, it's okay. So what are each of those base angles?
64.50.
So this is 64.5, 64.5. So now you've got the triangle on the left taken care of. Now we can use that right angle on the bottom there. Because two angles that form a right angle are complementary to one another. So what is left over to get to 90 from 64.5?
25.50.
25.5? So that means this part here is 25.5. Now notice again, we have an isosceles triangle on the left. All right, I kept my lefts and rights mixed up. It's on my left as I'm standing here.
On your right.
On your right.
Yeah. So.
I have an isosceles triangle again with a 25.5 base angle, which means my other base angle has to be
25.5.
25.5. So what's 25.5 plus 25.5?
51.0.
51. So what's left over?
129.
There you go. That's how we utilize isosceles triangles or equilateral triangles, by working through diagrams via just subtracting from 180 a lot of times. Okay? It is not a very difficult thing at all. It's back to, hey, look at this. No proof. It's back to some very easy algebra. All right. Question on that? Okay. Yeah, I was looking ahead and trying to figure out which one to do. I don't think so. Let's do do number 11.
Oh, yeah, we need to do that.
Number 11, is there a picture? You want to draw a picture?
So take a second, look back on your notes about how you're drawing a picture of an isosceles triangle, and see if we can figure out all the measurements of the sides. Because drawing the picture and labeling it is how you're able to solve the problem.
Minus 11. You get 169 big one. 60 by 160. Actually,
I'm for it. I'm okay with that. All right, so hopefully, you guys, when you drew your diagram, did this problem tell you which letter specifically was the vertex angle? No, so which one does it have to be? E, very good. So we'll just go D, E, F, which means these are the two sides that are going to be congruent. So fill in the blanks. DE, x plus 7, DF, 3x minus 1, and EF was, bless you, 2x plus 5. So in order to solve for x here, which two sides do we set equal to each other? Very good. That's the idea. If you have to be able to read the diagram to know which ones to make it work. Subtract x, subtract 5, you get x is 2. Yes, sir?
What's DF's?
3x minus 1.
Oh,
Come on, you can't figure out my chicken scratch?
and I wasn't sure if it was an unfinished 4 or not.
So if x is 2, all you do now is substitute back in to make sure everything works. What's 2 plus 7?
2 plus 7 equals 9.
What's 2 times 2? 4 plus 5 is? 2 times 3 is? 6 minus 1 is?
5.
Therefore, there's all your side lengths. Hey, were the two sides that we said congruent? Are they congruent? Yay, so that's a good sign. Hey, you know what else we'll be able to do eventually? Eventually, we'll be able to figure out all those angle measures as well.
That's not.
That's just some buttons on the calculator. You can't do it. You have no idea. You don't know how. Seriously, you don't know how. There's no way you know how to do it. I guarantee you. Let's see here. Water. Flip it over to the next one. Not saying that you couldn't figure it out, but as of right now, you've probably never seen it. Look at 13. This is another really good one for isosceles. Excuse me. So, on 13, does everybody agree we've got two different isosceles triangles? Okay. Now, we need to solve for x. In this case here, are they dealing with the side lengths or are they dealing with angles? Angles, good. So, I'm given the fact that this 2x is here, which means vertical angle, very good, it's also here. Now, if this is 6x plus 6 at angle T, what does angle D have to be? This also has to be 6 plus 6x. So now you have all three angles inside a triangle. What do they have to add up to equal, guys? Wait.
Sorry.
Okay? That's the idea here. Using vertical angles. Bring it into another diagram. Some of the interior angles of a triangle is 180 degrees. I think you guys have known that for a very, very, very long time. So we have to combine our like terms here. 6x, 6x, and 2x. Well, 6 plus 6 is, plus 2 is 14. So we wind up with a 14x plus 12 is 180. It's nothing more than a two-step equation then. What do you do first?
Subtract 12 from both sides.
Good.
Divide both sides by 14.
Absolutely.
Very good. Okay. Want me to step on your foot? No, start being your foot then.
Let's do it.
No. Do 14. Take a minute, do 14. Okay? Take a second, try 14.
For numbers 13, what was x equals to?
12. Take a second and do this one.